Let's talk about painting pixels and something actually you worked on that is also at the intersection of things we talked about. And one thing you worked on is that, okay, so we love reanimated, we love animating stuff. And so the way reanimated works is that you give it a component, it looks up the underlying native component, or these are the properties. And instead of updating the properties via the JavaScript thread, I'm going to do it directly on the UI thread. And so we love it, but of course, there are a couple of use cases where this model doesn't fit quite well. One is a text component, because value you want to animate is a child and not an attribute. So reanimated doesn't know, there is no semantic for this. And so what you did is that you forked and you moved it into an attribute.
Yes, the React Native animated text will fix this, but then of course it's a trade-off because you can't, because it's not a children anymore, but just a string.
And um, and then there's a second use case, which is OpenGL, where here it's not a property. You just have like this imperative API. You have this GL object with these functions. So it's a WebGL API, and then we animate it. So here again, there is no semantic to automatically animate yeah the properties on the UI thread. And I think it's quite important to be able to animate, paint pixels on the UI thread efficiently. So the way the WebGL API works in Expo is that it's using GSI to do the calls directly. So from JavaScript, it's a native call to the C++ API. But then if you're animating something, you still have to go from the animation thread to the GS thread to make the JavaScript call. And I was investigating a way to, so we could animate these things entirely on the UI thread, because I think if we can do performant graphics in React Native on the UI thread, it can unlock a lot of things. For instance, in the SVG module, there's a support for filter missing and things like this. And yeah, I think if we can paint a pixel in a performant manner on the UI thread, that can be very good.
Yes, indeed. So OpenGL is like insanely fast. Uh, we would love it so much if we could get this performance in like other areas in React Native. So it's good that we have access to it, but what you're saying is that because we sometimes have to cross the bridge, it's a huge bottleneck.
I wouldn't say a huge bottleneck again on iOS, because the platform is so fast. It's actually like pretty fast. On Android, it's a bit of a bottleneck. But again, it's interesting because here, even if you do native development, the Android platform is just much less powerful. And it's incredible to see the differences. So, when we're doing React Native, first we're like, oh, the native side is a black box. And as soon as you start to open the black box and see what's going on the native side, it's pretty insane to see the differences. An example you mentioned so many times is a masked view, where on iOS it's a primitive, it's completely hardware accelerated. You can animate it, no problem. And on Android, for every frame, it takes a snapshot, so a screenshot of the image, applies the mask on the CPU, so everything is done sequentially, and then renders. So it's crazy. It's much slower. It's not hardware accelerated, and then of course you run this on devices which are not as powerful as iPhones. So things are tough. First, I was wondering what is the general purpose API we should use to display things. And I guess it depends on your use cases and so on. But on one hand, WebGL seems to be the standard, right? It's used everywhere. It's used by 3GS. We can use to do 2D things. So probably the right API is WebGL. And I really hope that at some point we can animate WebGL on the UI thread. In React Native, I think that will enable a lot of possibilities. I'm not sure how hard it would be, but for instance, we could rebuild maybe things like SVG filters on top of using WebGL and things like this. And so we would have like this general purpose graphic engine in React Native. I think that would be nice.
Yeah, it's very interesting, especially since I think WebGL it also has some support for then like again embedding like web content, not non-GL web content inside the canvas again. I saw that this is a feature of React Tree Fiber, and that is actually necessary if we want to like mask a
Exactly.
non-GL view in GL.
Yes. I think it's probably a lot of work to get there in React Native, but yeah, I hope that we will get there. And so I was thinking, okay, what is an API that is animatable for OpenGL? And do you know about GL React?
No.
It's really cool because it's really OpenGL. What I really love about GL React, so okay, 3GS is for 3D, but of course, if you can do 3D, you can do 2D, and you can do a lot of great 2D stuff in 3.js. But GL React, so it's for 2D shaders, but the model is like super well done because it's really how do you say, really made tailored for React. So it really makes sense. So let me maybe show you quickly. So actually, the way the API works is really fits with the React model. So here you see we have you give a fragment shader. So you have a default vertex shader, which is basically the your view, and you have it as a UV vector. So here you have the position of the pixel, and then you can draw on each pixel. And so it's a very, and here you see you have a concept of uniforms, which are variables you can pass to the shader, and this is what you can potentially animate here. And so very simple API. Here it's an API that fits with React. So we have properties, so it's something we can animate. And of course here, because it's done using WebGL, it's only can be animated through the UI thread, through the JavaScript thread, sorry. And so what? So the API I like, and it's very also so composition model a la React. Also, you can nest these components. So it's like a tree, and then you can access the children as a texture of. So you can have like a blur shader which receives as parameters the children, which is maybe so you can do a lot of nice things. Maybe yeah. So here maybe you have a shader that displays the image, a shader that crops, and you simply can nest these things nicely. I think there's a couple of couple of nice examples.
Wow, yeah, it's really nice and it's like interesting that this has like such a you wouldn't expect this to have such a high performance because what you are doing is like if you move these sliders, you are updating the React state, doing a new React render, then updating the shader source code, and then passing it to the WebGL context, which probably has to kind of like recompile or reinterpret um, the shader. It sounds like it would be slow, but actually the bottleneck I think in web and also in React is just like painting these views and texts, um, and therefore it might be unintuitive, but this is probably much faster.
So in these demos, which are web, indeed it's a React render. Every time you update, there is a way to update the properties without. So like you know how you do set native props in React Native to update a property without from the JavaScript thread, but without triggering re-renders. You can do it with this API. And then you don't recompile the shader, and you only update the uniform variables. So the shader is compiled and you just update the variable, which has also a small performance cost, but I guess that works.
Oh, I see. So you can pass variables to the
Exactly. It's
shader,
called,
and
this is
therefore,
what uniforms are called. So are these, you parameterize your shader with these variables, and these are made to be updated. Yeah.
okay, yeah, that makes sense. That saves a lot of time for sure.
So I was like, okay, this is a cool API, but again, I think the holy grail will be to have WebGL support fully fledged on the UI thread. But I was like, let's just run a fun experiment. This is an API that is potentially can be animatable directly. And so I built a small extension from scratch on iOS and Android that implements this API. Actually, a simpler version of this API. And first of all, so to build the native module, I used Bob, and it gives you the boilerplate for the native code. Is that what you used also for the animatable text?
Yes, I you would spend a lot of time setting up React Native project and all the boilerplate without this Bob tools. I think it's the de facto standard.
It's incredible. It's absolutely amazing. And then I picked. So he's asking you which languages you want to do. I mean, yeah, like the wizard is so good, and so I picked Swift and Java because I learned it at school. But actually, I think Kotlin is really the way to go, and especially I feel like so Swift UI, Swift felt very close to TypeScript, so some syntaxes are exactly the same, and I guess Kotlin also there is a lot of similarities, and now also a lot of examples and resources are in Kotlin, so I think it might be worth like now to go Kotlin also, Swift Kotlin.
Yeah, definitely. I would have to relearn it, but I think many concepts you can keep, and Kotlin just allows you to write in a much more concise way, just like um, Swift is. I think the difference between Swift and Objective C is much crazier. Like Objective C is so convoluted and nested and verbose that yeah, it's basically just. I see it as like not that many different, not so different languages, but with a lot of syntactic sugar applied.
Yes, Swift is amazing because I didn't know the language, but because the language is so close to TypeScript, and then because also the Xcode editor is pretty good, I could like build a demo quite easily without knowing the language, without even like seeing a tutorial about the language. I think it's quite impressive that
Yes, and
you can
now
go this
async
far.
await is coming
Yes,
into Swift, so this is a good card that gets played into our React
yes.
Native developer hands.
Yeah, so really, and I think it's quite so with Bob Builder and now using these high level languages like Swift and Kotlin, you can really build a React native module in minutes. It's incredible, and I think it can really solve your problems because you can, oh, no problem, I just go on the native side, and if something is, again, the problem is that on iOS you access this incredible platform, and Android things are more difficult. But so here I created a small library. It's only a proof of concept at the moment. It's called Shader. I mean React Native Shader, and it provides a shader component. So a bit like what the way GL React works. So you have the source of the shader. So here I copy pasted the source code of a shader from GL React, and then you can pass your uniforms. And here, your uniforms we pass as an animated prop. So here, what you see on the right side, oh, sorry. What you see on the right side here is completely animated on the UI thread. So there's no JavaScript code executed. So we have an animation value from reanimated 2, a time uniform, which is available from the shader.
Wow, really cool. So amazing that it works super well together with Reanimated too. They probably did not even intend it for this use case, but wow. And then, so the uniforms, they are like the props of a shader.
Exactly. That's a good way to put it. And so on iOS again, okay, you want to compile and run a shader. You have so many options to do it, and they're all super performant. So you can use OpenGL, you can use Metal, which is their new graphic APIs, and apparently they are advertising it as being incredibly fast, and it seems to be incredibly fast. And it's very easy, and in a few minutes you're done. On Android, then it's a completely different story.
Does it run on Android yet?
This runs on Android.
Oh, okay, well done.
No, not not right. So on Android, it's using OpenGL. But so first of all, to build the code is much more complex, or at least it felt way more complicated. And yeah, and I don't. It's not as fast as.
Yeah, but still, this is. I mean, you don't even need the most. It's not like we need to start off by making like a video game right away. Even with a bit of non-optimal code, this is probably insanely performant. I wonder, do you want to open up the and show the native implementation
Yeah,
also?
absolutely.
Or?
Okay, so the native code, yeah, thank Bob Builder. I mean, absolute game changer, incredible. And I'm so glad I wrote this small extension because now it makes me realize if I do React Native development, I can access the native side like so easily. It's like, and also it just makes you more confident about making a React Native project, knowing that if you get into trouble, you can do like the custom thing you need on the native side like super easily. So this is the
Should we
Java
start
stuff,
that with
but
the Java? Okay.
I'm not. No, the Java stuff I'm really not proud. I mean, I followed the OpenGL tutorial. I mean, the tutorial actually was super well done. So here you set the uniforms, which you get as a prop. I mean, I guess it starts here. So you set up, okay, your properties, and then you set the uniforms, and then, yeah.
I see. And you use the add whitelisted props method from Reanimated to make the uniforms method property animatable.
Yes, but I think now it's done automatically, actually.
Oh, cool.
In create animated component. I'm not 100% sure, but it should be, I think.
Okay. So one can just test it out.
But here
Interesting.
I have the default vertex shader here, where basically my vertex is view. So this is where
Okay, so what is a vertex shader?
That's a good question because I'm actually not sure. And actually, okay, yes, and actually that's a funny story. I mean, now I think how would I? You see how if you cannot explain something, it means you don't understand it, and I think I really don't understand it enough to explain it. Like a fragment shader, this I can explain.
Okay, so but that's that there are different types of shaders, the
Yes.
vertex shader and the
And
fragment
fragment
shader.
shader.
So does like the fragment shader maybe like determine which color a pixel is
And the vertex shader is your shape, right? And I think this is
Yes,
where you
makes
apply the
sense.
transformation and so on. And then the fragment shader, you paint the pixel.
Let's I don't have any idea either, but I think we can go with this assumption
Yes.
and continue.
And in fact, my vertex shader is the square here that represents the view. And basically here I just give this. You know how you said uniforms are like properties of shaders, like in React? If you make the React analogy, then you have, you have attributes, and then you have varying, which are data shared are like properties but shared between vertex shader and fragment shader. So it's like a context. No, I don't know. Maybe the comparison stops here, but so you have attributes varying, which are variables shared between shaders, and then uniforms, which are the variables you update. And so yeah, so I have my vertex shader, the fragment shader, it's the one provided by the property, and then you have to do all these things. So to compile the shader and attach variables. So here draw is invoked on each frame, and on each frame I go through the list of uniforms, and I set, okay, you see this is where it's only a proof of concept because I only deal with uniform, which are numbers, but it can be arrays, can be vectors, mostly vectors, I would say. So yeah, um,
Yeah, pretty impressive. And I mean, of course, you started with a proof of concept.
it's a proof of concept,
Um,
yes.
I think nobody is surprised that it's not like full-fledged production ready, but you know, people. I think this has so many use cases, and people can need it. So I hope the community picks it up and
Yeah, and
like iterates on this.
yeah, so on Android it took me a lot of time and was tough to do, and on iOS it's so easy. It's really crazy.
Uh,
Yeah, you just and again, because I don't know if you realize, but in Java I had to, I mean, create a couple of classes, really pass things around, and really to think about things are pretty dirty actually. And on iOS, it's like only one file, and you say, okay, this view, it's I used Sprite Kit, which is a 2D. So you can use OpenGL. Here I use Sprite Kit because it's faster. It's a high-level API, and it's using Metal just to be fast. But then it's like so
that
fast.
should be super
You
scalable.
say, okay, this view is a Sprite Kit view, and you create your scene. You say, okay, this is the source of your shader. Applies applies a uniform present scene, and that's it. You're done.
One file. That's it.
That one file, and look how small it is.
Wow. That's crazy. And in the Java module you had to hard code some values, but here it's fully dynamic.
Yes.
Wow.
So
So this one is it's like, is there anything that one even could improve upon this, or is it just um,
I
so easy to just bridge native code with React Native?
so easy. No, this is nice. I mean here, um, because here on Android side we're trying to do something that is notoriously difficult to do even on native Android development. But imagine if it's something that is easy to do on Android native, then you see like it's incredible how easy it is, and I can only we can only encourage people to really try to open the to not see the native side as a black box, but try to see it as something you can easily hack into. Especially now, the timing is perfect because it used to be like if you're Expo and Expo managed, the native side doesn't even exist. But now you can have native code with your Expo managed project, and so the workflows are getting more and more agile.
Yeah,
So
this
the
will
timing to
be
get into native development a bit, if needed, is perfect.
this will be super nice. And um, like you just said, now with these new build tools, you can basically just casually create a new module and
So casual, yeah.
start out, write the code in Swift and
Yes.
um, Kotlin or Java or whatever, and just push it. And this is how it should be.
Yes, casual. It's funny the term you're using. Casual native module development
Yes.
with Expo managed, and it's like super casual, and you're like,
Yeah, actually, the I think the Swift part, this was seemed like, yeah, just pretty casual.
so casual.
Open shell bridging, pretty. You make it looks easy. Um, yeah, the the Android part we don't need to talk about.
But that's where also it makes you realize React Native and React, it's only the programming model. And then you need to leverage the best of whatever is on the native side. And so on iOS, everything is great. On Android, um, maybe it's Flutter. Maybe we need to use, because Flutter, I guess, is very good at painting things and at doing graphics. I assume because just of the way it's built. So maybe we.
This I also want to ask you another question. So we talked about different ways of how could we achieve. Like you always said your goal was I just want to render a triangle in a performant way.
Yes.
And there was also this thing standing in the room, Skia. So
Yes.
Skia, it's the graphics engine that's powering Google Chrome, as well as Flutter. And also, I think now it has something to do with this Fuchsia operating system from
Yes.
Google. So Skia, a highly efficient, performant graphics library. There's also React Native Skia, a React Native Skia renderer out there
Yes.
for React Native. But what it does, I think, is it just takes your React markup and instead of rendering it as like UI view and UI labels and then the Android counterparts, it renders it to a Skia canvas kind
Yes.
of. Did you experiment with this as well? Is this something that might have a future?
Um, it looks very interesting. Yeah, I like again that React is just a programming model, and then you can use any underlying technologies. The Skia API, I was super impressed. Like I loved it immediately, and because it does the low level as well as the high level stuff. And I just like the different level of abstractions. I don't know. I felt like the API was super well thought out. The problem is, and I was like, oh, you know what? Also, I thought life would be easy because I was like, iOS, Metal, you have this super high level API. It's so casual and it's just a good time. And then I was like, I'm going to use the Skia on Android. And actually, this is what I should do. But then I was just lazy because I guess the library is not so, because then you have to deal with the C bindings and so on. So it's not so trivial to, but maybe I should make an effort and really, because indeed the Java implementation should be done with Skia bindings on, and there are some Skia bindings on Swift also, but it's very experimental. I didn't want to mess around with it.
Yeah, interesting. Yeah, I think it has advantages and drawbacks. Of course, it would be like super good for cross-platform consistency and performance. From what I've heard, Flutter is just so smooth. But then, of course, you lose the advantage of React Native that you access the actual UI components that the respective SDK already provides. So if you want to have like a UI, if you want to have like a text input field that supports selection, copying, pasting, autocorrection, um, and all these features, then Skia is terrible for it.
Mm.
Um,
How long it's gonna take before someone does a renderer, a React Native renderer for Flutter?
yeah, it's could happen. We should check. Maybe it's already out there.
But this, it's funny because the first time I heard about Flutter, I was like, oh, it's like an operating system because it's just painting everything from scratch. But now Fuchsia OS, which is the Flutter, I don't know much about the details of these things, but it feels like, yeah, it's a Flutterized, it's a, how do you say? It's the operating system version of Flutter, essentially. That's how it sounds like.
Yes, it is. And yeah, it's so like Google, they are still. I think the recommended way is still to just yeah, you should use the Android SDK and you should use Flutter is like the same way as React Native. It's not the optimal thing to use, but it makes sense if you want to have like a cross-platform
Yes.
experiences. And then with this text input fields, like or like all these fine-grained APIs which are not accessible, that I think is the huge drawback.
Mm.
I think in the early days of Flutter, it could not even properly display emojis,
Yes.
and that is of course extremely trivial if you can leverage the already existing native APIs.
It
So ideally, we can find some crazy hybrid, which, but of course, we will never reach a perfect solution. I guess it's a dilemma.
mm. It's interesting because I think I might be wrong about the Skia renderer proof of concept, which got a lot of attention on social media. I think was done on iOS only, where actually that might be on Android that it should be very useful, right? Because on iOS, if you're a React Native developer, life is good on iOS. I mean, unless I'm mistaken, like, you have a super fast platform, super fast APIs. You can connect to these native APIs super easily. I feel like life is good. It's more on Android that you want to have like super powerful APIs. And this is where probably a renderer, Skia renderer for React Native Skia renderer would be very useful. But then basically you're maybe rebuilding Flutter essentially. So maybe you need the Flutter renderer on Android.
Yeah, that's
And maybe that's what
that's.
Fuchsia OS is. I don't know.
I just had another idea which I think could maybe make sense. So right now, I think Google Chrome is using Skia to render all of its content. So I assume it would also render all the SVGs via Skia. What if we try to port React Native SVG to Skia so that we could, and then take the code from Google Chrome and port it so that we could draw all the SVG features like filters and masks as well.
Absolutely. And you have the rasterization of. So it seems like in Skia you have access to all the fancy rasterization techniques and so on. So yeah, it should be doable. Then again, the masking stuff, it's about how do you access. I don't know how it works, but if you have like a view, a React Native view, which is like foreign, how do you access how do you say, the screenshot or the snapshot of the view, which has nothing to do with your Canva or I don't know.
There's it's so cool because there's so much experimentation that
Yes.
can still be done, and some revolutionary stuff that can still be developed. So I think just because there's opportunity, it means that innovation in this space will probably never stop.
Yeah. So exciting.